But today we'll try to check the consistency of an equation. To check the second application, so consistency of an equation. Just a minute, ma. Disturbance around. Ma, to check consistency of an equation, so we'll try to use dimension analysis. Ma, before going into that, we just remember this master equation or master formula. Assume whenever there is a physical expression, if physical quantities are separated, if physical quantities are separated by plus, minus, equal to, less than, greater than, then they have same dimensions. They have same dimensions. Just remember this one. Ma, if what is the meaning of this one exactly? Ma, you can say that you can add only 2 centimeter alone, right? Even you can remove 2 meter in 2 centimeter. I mean, they have same dimensions. Meter I have taken, here centimeter I have taken. This is nothing but length. This is also nothing but length. You can remove or add length from length only. You can equate length to length only. You can't have this one, right? 1 kg to 2 meter. You can never have this one, right? Whenever any physical quantity, 2 or 3 physical quantities are separated by plus, minus, equal to, less than or greater than, they will always have same kind of units, same kind of dimensions they'll have. So first I'll try to do this one. How to check the consistency, no? Can anyone tell me one of the kinematic equations, or I'll take the kinematic equation. Can I have this one as S equal to ut plus half at square? I want to check the consistency. So far, how far it is true? Whether this equation is true or false. Assume that this is new equation to us. Somebody gave you S equal to u square t cube plus half into a t power 4. If they give you this equation, so it is new to you. So how to check the consistency? Each and every time I told you, this is unit of what, ma? What is the unit of distance? A dimension formula for distance. L power 1, right? Yes. So you can write here, dimension of it is nothing but L. Ma, this is nothing but velocity, L t power minus 1 into t. Just go with the dimension analysis. Plus half is not having any dimensions. Half is just a value. Neglect that one. And acceleration L t power minus 2 and t power 2. So t power 2 and t power minus 2 gone. T inverse and t is gone. So length is equal to some length plus some length. Yes, length is added to length. And this is also length, which is equal. So I can say that yes, this equation is dimensionally consistent. This equation is true. If you see here, length equal to some L square t power minus 2, here t power minus 3, and this is turning out to be some L t power minus 2 and t power minus 4, t power 4 is coming. Here some other result you are getting, isn't it? T power minus 5 you are getting and L t power 2 you are getting, which is equal to this one, which will be never be true. Length can be equated with length only, or length can be added to length only. Okay, fine. Yes. Is this clear? Based on that, let us solve a simple sum. Let me see who will solve. This is most commonly asked question in competitive exams. See, assume you have a quantity like this. P is nothing but some b minus x square divided by 80. Fine. Where p is power here and x is nothing but distance and t is time. And t is time. Then what you need to find out, find the dimensions of A and B. Easiest question, ma. Find the dimensions of A and B. Give it a try. We'll give us 30 seconds. Make it fast. Okay. They have given this as power. Power can be equated with power only. So this whole set is nothing but power. Okay. Power, how can I take it? Dimension formula. Usually the formula is nothing but work done divided by time taken, isn't it? Work done divided by time taken. So work m L square t power minus 2. Time here you can take it as 2. So dimension formula ml square t power minus 3, you can take it directly. That is equal to some whole dimension formula of b minus x square by 80, I can take it. First try to have this one, b minus x square. Analyze this fact. X square, what is the dimension of this quantity, x square quantity? Can I say it is nothing but length square, no? So what is dimension of b? See, length square they have taken. The b must also be length square, no? Dimension of b must also be equal to length square. Then only from length square you can remove length square. Assume this is area, this is also area. Like that you must take it. Dimension of b is directly taken. These two physical quantities, b and x square, are separated with a negative symbol. So they will have the same dimensions. Clear? Now this fact is holding true. See, if physical quantities are separated by plus, minus, equal, less than, or greater than, they will have the same dimensions. Minus I am using now. Yes, b minus x square. So whatever dimension for x square you are having, the same dimension of b also. Okay, we are done with one. So how to find out AT? How to find out dimension of A? We don't know what is dimension of A clearly. Everywhere here it is multiplication, here it is division. We'll do one thing. We'll try to go with the original equation. Power is nothing but mn square t power minus 3, which is nothing but, this is, can I write it as some length square and length square? Assume 4 meter square and 2 meter square. Assume again length will only come now. Let me write it as a single length square divided by a into t power 1. Okay, L square and L square is gone. A you can directly write it as m power minus 1 t power minus 2. Just a minute, t power plus 2 will come. Clear, everyone? M t power minus 2 equal to A. Good. Correct, Parbiju. These are your questions. Let us go with the next sum. We'll have a nice amount of problem solving. Now assume that the velocity of the particle is given. Assume v is nothing but some a plus bt plus c by d plus t. Here v is velocity and t is nothing but time taken. Now what are the dimensions of a, b, c and d? That is the question. You don't need to think much about it. Use a fact. Okay, let me see. I'll give you 15 seconds for this. Now velocity equal to this one. What is dimension of A first? Velocity must be equal to velocity only, no? So dimension of A is nothing but velocity directly, which is nothing but Lt power minus 1. Okay. Yes, Lt power minus 1, correct, ma. So next, Bt must also be velocity. Then only velocity plus velocity will be equal to some velocity. 1 meter per second, 2 meter per second, some 3 meter per second will give you some 6 meter per second. Like that, we must proceed. So here also, Lt inverse will come. But here one more t is there, no? If it comes this side, B will turn out to be Lt power minus 2. Good. So far I'm getting the correct answers. Good. Correct part. So from here, we'll try to have the dimension of D. Simply by closing your eyes, you can say the dimension of D. Why? D and T, they are separated with plus. So you can say that dimension of D is nothing but time. T power 1, you can write it. Now C, we need it. Okay, that's a major thing. Can I say C by D plus T is nothing but velocity? Yes. So you can write it as C by length plus length. I'll try directly take it as length alone. Okay. The next step I'll take it. C divided by length alone. 2 meter or 3 plus 3 meter, 4 plus 4 meter, something like that. It will be again a length. Instead of taking 2 times, I'll take it as only 1. Oh, sorry, it is time now. So you can write it as T. So instead of taking 2 seconds, 3 seconds, 4 seconds like that, I'll likely try to make it as T, which is nothing but LT power minus 1. So dimension of C is nothing but L alone. T inverse and T will give you L alone. Good. So far whatever I received the answers, all the answers are correct. Good. Hope this is clear. No issues with any of the questions. Fine. Well and good. Last is some based on the consistency. Okay. So I'll give you an equation. Just take it as P equal to M1 plus M2 times of X divided by A. Here I should define the quantities, right? So let me say that P is nothing but pressure. Okay. And M1 and M2 are the masses. Okay, instead of saying they are the masses, we'll do one thing. Just this expression refers to the pressure. Fine. Now I'm asking you, what can be the possible dimensions of M2 as well as X? Nothing I have given. I'm just mentioning it as P is pressure, and even you can take A as area. Now, what are the dimensions of X as well as M2? We don't know whether it is
force by area.
Yes, force by area. Good, exactly. So this entire quantity must be equal to force, right? Proceed.
M1 plus M2 is force.
M1 plus M2 into X is force.
Yes, sir.
Yes. Yeah. Try to proceed with that. Good, correct. Even I'll give you one clue. Just try to take M1 as mass per. M1 is nothing but mass. Then directly say M2 dimensions are nothing but mass again. So from here, the pressure you will get it as some mass times of X divided by area. So pressure is nothing but force by area, no? So MLT power minus 2
X equal to A.
L square. Yes. So this one will turn out to be ML inverse, no? So ML inverse T power minus 2 I'm getting. So if you want X, so you can have it as ML inverse T power minus 2, which is nothing but MX divided by, so L square I'm getting, M and M may be gone. So I'm getting L power 1 and T power minus 2. X. Directly take it, M times of A. MA by, see MA is nothing but force now. Force divided by area, you can write it. A direct step you can take it. If you don't know the formula, you must go with this. This is nothing but the acceleration. Yeah. Meter per second square will get, no? In the same we are getting. Dimensions of M2 is nothing but, you can write it as M. Dimensions of X is nothing but L into T power minus 2. Clear for everyone? Yes. Okay, let me proceed further. The third analysis we'll see. To deduce the relation between physical quantities. So if we know the dependency, based on the dependency only we can say, assume that force depend on these factors, the other thing depends on these factors. Based on that only we can say. Even centripetal force we know, right? I'll do one thing. I'll try to take a question. From the question, I'll try to explain. See, we know centripetal force. Assume centripetal force F depends on, let me say, mass of a particle, comma, velocity and radius of the circle. Fine. So I'm asking you, derive the formula. Derive the formula for centripetal force. You guys know. So what is the formula for centripetal force? What I want you to tell you, what I want to tell, by any chance, if you don't know, a new formula came. They are asking a viscous drag in a fluid. Fine. In mechanical properties of fluid, you'll get a viscous drag is proportional to eta. It is proportional to size of the object. Like that, they will say. From that, you can deduce any relation. You can make your own formula. Okay. Good. Correct, Brishu? So F I can directly say it is proportional to mass of the particle. It is proportional to velocity as well as it is proportional to radius. I'll try to have this one A, B, C. I'll try to write it. Yes. MV square by R. Correct. So instead of taking proportional each and every time, I can equate with the constant. So M power A, V power B and R power C, I can make it. Dimensions of it can be taken ML T power minus 2, K, M power A, we know LT inverse, whole power B and L power C, we can write it. Now, try to equate all the quantities of mass as well as length as well as time. Okay, M power 1, L power 1, T power minus 2, I'll have. My constant, I'm taking it as 1, M power A and L power B plus C and T power minus B. Just try to equate powers of the quantities. You can have M power 1 equal to M power A as well as L power 1 equal to L power B plus C as well as T power minus 2 equal to T power minus B. From here, just by looking, you can say A is nothing but 1 and B value is nothing but 2 and value of C is nothing but, so you can write it as, okay, B plus C is nothing but 1, no? Value of this one, you can write it as, okay, I'm getting minus 1. Am I?
Minus 2 should be.
It should be minus 2 V square by R. Okay, minus 1. It's correct only. So the whole expression I can write it as, so F, I can make it as M power A, no? M power 1. So V power 2 as well as R power minus 1. You can write it as MV square by R. Instead of writing as a dimension formula, I'll try to write it as a formula. So F is nothing but MV square by R. Now this is how all the scientists will frame the equations. They'll formulate. So this is something, mass is something, force is something, acceleration is something. Based on the dependency only we can frame it. E equal to mc square is there, no? That is also framed from the dependency, you can say. Right? Okay, good. So we no need to discuss much on this dependency, man. So if you know how one factor depends on other factor, you can just frame a formula like that, I can say. So there are some limitations of these dimension analysis, man. So we'll just discuss about the limitations. What are the major limitations? So what are the limitations of these dimension formula? You can clearly say the value of the constants can never be found out from this. The value of constants. Which constants I'm referring? See, while reducing the relation, this k value is there now. I'm taking it as 1. But sometimes it will turning out to be 2 pi. Sometimes we'll take it as 6 pi. From experiment only, we can say that this constant equal to this much. From the dimension formula, we can never say that. The value of the constants cannot be. Okay. Cannot be found. Okay. And one more thing, with this method, we can say that the equations containing, assume that there are trigonometric quantities. Trigonometric quantities, as well as if you're having log quantities and exponential quantities, you can never analyze. This is a major fact. We cannot analyze. Fine. I'll just give you an example, random example. Assume that force is taken to be some m times of AC, something like that, and sine of bx plus cd. They'll ask you, what is the dimension of bx plus cd? Sine of whatever is there inside, this entire quantity is dimensionless. We'll try to solve some sums based on these examples too. Even if you have an equation like this, e power minus ct divided by d, this entire quantity minus ct by d is dimensionless. As well as, so logarithmic quantities, assume log of x plus y. X plus y is dimensionless. These quantities can never be analyzed. Okay. Or I can say sine theta. What is the dimensions of theta? What is the dimension of theta, ma? Theta is a dimensionless quantity, no? E power something is also dimensionless. As well as log of something is also dimensionless. You can remember like that. Clear? And just tell me, what is the dimension formula for work as well as energy? Dimension formula for work as well as energy, they are same. ml square t power minus 2. Usually there will be a confusion with these dimension analysis. So many physical quantities are having same dimension formula. So based on the dimension formula, we can never say, based on the dimension formula, we can never say which physical quantity it is exactly. Which physical quantity exactly. Okay, whether just by looking, I cannot say that it is energy or work done. If you know physical quantity, then you can frame the dimension formula. But if you don't know what is a physical quantity, so you can never say that which physical quantity it is associated with. So there are multiple options which you are getting now. Okay, clear? Shall we switch a bit?
Sir.
Okay. So far we have learned about physical quantity. What do you mean by a physical quantity? A formula for physical quantity. And we have seen the ratio type, vector type, and scalar type physical quantities. Later we have jumped with system of units. We have seen basic physical quantities and dimension formula, fundamental and derived also we have covered. And applications of dimension analysis. First, to convert one system of unit to other system of units. Next, we have taken to check the consistency of an equation. The third, we have seen how one physical quantity depends on other physical quantity. Based on the dependency, how can we frame a formula and limitations. All these things we have covered so far. Okay, these are major topics on just the theoretical portions. You can take it. At the end, we'll try to solve more and more sums extensively. Okay, in one of the sessions, I'll try to cover. Right? Okay, now let's discuss about significant figures. Significant figures, this is most easier topic. In chemistry too, in +1 or +2 you will get it, isn't it? The very first chapters, beginning chapters, you are going to get it. Now, what do I mean by significant figures? Assume that I have given an example. So this is Chennai. So here somewhere Delhi is there. Assume somewhere you have read. So from Chennai to Delhi is nothing but some 576.8 kilometer. A random number. Fine. So I've asked some 7 persons or 6 persons. Person 1, person 2, 3, 4, 5, 6, 7. So I just asked, what is the distance between Chennai and Delhi? They know 576 for sure. Even I'll add one more word. So a person A is saying, I know just 576 kilometers. A person B will tell, so 576.99 something. Person C will say that 578 point something. Everyone is sure about 576, around 576. They are not sure about 0.82. So a quantity or a number which is more reliable and which is more certain. Whenever you are taking a measurement where you are having more confidence about a number, that number or that digit is known as a significant figure. Okay. In a measurement, most reliably known number, I can say. Or on which we have confidence about. On which we have confidence about. Isn't it? Okay. Let me go for small rules based on it. So when we can say that this is certain, when we can say that this is uncertain. We'll go for rules for significant figures. So we'll just mark it as rule 1. Assume that you have non-zero digits. All non-zero digits, whether they are significant or not, are always significant. Assume you are having some random number. So 2, 6, 5, 7, 8. All the numbers are significant. The number of significant figures will be 5 over here. Okay. Let me take it as this is number. This is number of significant figures. Now I have taken non-zero. Okay, 0 numbers I'll take it. Zeros at the end are never be significant. Without a decimal point. Without a decimal point. Okay. So I'll take it as 3600 like that. So how many significant figures are there? Zeros at the ends are never be significant without a decimal point. No decimal point is there. So you can clearly say that there are only 2 significant figures. Like that you can make a statement. I'll add one more word. If you are having the same zeros in between 2 non-zero digits, are always significant. Okay. So you can always say that, assume I'm having some 3652. How many significant figures are there?
6.
6, exactly.
6.
Yes, 6 significant figures are there. Good. Now we need to discuss with points. So whenever, assume that a number is less than 1 and the zeros are there right to a decimal point but left to a non-zero digit, they are never be significant. Assume that if a number is less than 1, okay, and the zeros are after decimal and left. Of the non-zero digit, I can say, are not significant. See, what I meant to say usually, assume you're having 0.00572. Now, how many number of significant figures are there? This number is obviously less than 1. Now, you can see right after decimal, there are 2 zeros. Yes, right after decimal, zeros are there. And these zeros are left to a non-zero digit. These 2 zeros will never be significant. Only 3 significant figures are there. Clear? Yes. Good. Correct? Good that you guys have more clarity on significant figures. Nice. Okay. So trailing zeros we have always seen. We have taken zeros at the end. Zeros at the end, they are also known as terminal zeros, which are at ends. Okay. They are also known as terminal zeros. Well and good. By any chance, if there is a decimal point, right after decimal point, if there are any significant figures after a non-zero digit, they are significant. Assume I have taken this part in a number with decimal, zeros to the right of non-zero digit are significant. See, I want to say even if a number is 0.005200, this value is significant. You can say 4 significant figures are there. Even if I'm having 0.00290, so you can say 3 significant figures are there. These ends right after decimal, after a non-zero digit, they are there, right? So only they are significant. Even right after